Okay, so, congruency. If you don't remember that congruency symbol from chapter 1, way back, it is, it is this symbol. It's an equal sign with a little tilde above it. That's the congruency symbol. It's an equal sign with a tilde. Now, why they actually use it, they're comparing two objects, two geometric figures, and saying that they're congruent to each other. So, like for instance, triangle ABC is congruent to triangle DEF. Like that. That's how they use it. They compare objects. Now, why we have an equal sign, that's when we compare like algebraic stuff. This formula is equal to this number, or this formula is equal to this formula, and then you solve for x or whatnot. But objects, physical like geometric figures, can be congruent to each other. Now, what do we remember about the definition of congruent? This has been on almost every chapter test that we've had vocab on. No joke. It was on like 4 chapter tests. What was the definition of it? What does congruent mean? You guys remember? What do you think? Simple definition, please. No, not equal 180. It has something has to be equal. Okay, 2 objects being equal. I agree. In what regards? They're equal in 3 objects. So there's 3 stipulations for it to be congruent. It's equal in
size, shape, and measure.
Yeah, size, shape, and measure. Good memory. Size, shape, and measure. These are the 3 stipulations for something to be congruent. That was from chapter 1. Good memory on that. Size is like proportional. They're proportional. There's a scale, like a little model car is scaled down from the real car. There's a proportionality to it. They look similar, right? Their shape, the overall general shape of the object looks the same. It's not noticeably different. And then the measure, every measurement in this object is exactly the same. The angles, the walls, everything, they're identical in every regard. That's what we're going to be going into. So today, remember, the goal is just to intro this vocab term. The examples we're going to get to eventually for the homework are pretty like they're very particular in what they want you to know. So today, remember, I'm just introducing the words in the vocab today. That's all I want to do. I don't want to go too far in depth. But questions on any of that term or that definition? That was from chapter 1. That was like the first week of school. That's a pretty good memory. We've had that on 4 chapter tests with vocab, so you probably should know that word by now. So, all right. But let's jump into the theorems, and then we'll end with the what we're going to be going into. Okay? Because I said I didn't want to take more than 10 to 12 minutes here. The third angle theorem. This is our new theorem. It's theorem 4.3. We've had 2 theorems up to this point. Remember, the first theorem was the angles of a triangle summed to be 180. Right? They add to be 180. The second theorem we had was the remote interior theorem. The exterior angles equal to the 2 on the inside added together, but don't touch it. This is the third theorem. 2 angles of one triangle are equal to 2 angles of another triangle, then the third angles have to be equal or congruent. So we're comparing 2 different triangles. In fact, I'm going to draw 2 triangles here. Boom and boom. Okay, and I'll give you some letters here. Let's say this is A, B, and C. And this is D, E, and F. And they're saying that 2 angles are equal to the other triangle. So, for instance, I'll just put the markers in here, and I'll let you guys make up numbers here in a minute. It doesn't really matter. So that angle A, let's say that's equal to angle F here. Just kind of put them in a random spot. So angle A and F are equal, so that's one angle. And then there's another angle, let's say angle E is equal to angle C. So I have the little double bubble marker, so that means E and C are the same. So A and F and E and C. What we're trying to show is that B and D are the same angle. Okay, so I'll let you guys make up any numbers you want just to prove this point. So make up any two numbers you want, just don't make them so that they add up to be more than 180 degrees. So you can pick any two numbers you want. Two numbers, throw them out there. Not all at once. Two numbers. Say it again?
7.
7, okay, I'll go with 7. 7 degrees, and 7 degrees. And what was another number that you like to pick? Something a little bit bigger than that. Please.
68.
68, okay, I like that number. Okay, 68. Okay, we're going to go with those two numbers. So 68 and 68. Okay, now, again, these triangles are not drawn to scale because I let you guys pick kind of the random numbers here. Okay, what we're trying to show is that the third angle, the one that I do not have marked, are supposed to be equal to each other. It's kind of a no-brainer. It's kind of a common sense thing. But I'll show you kind of how the book does it. It doesn't matter for the triangles. When you have a triangle, what should all the angles in a triangle add up to be? 180, right? That was the first theorem we learned. So this is the way the book shows it. They say, okay, for the first triangle, angle A plus angle B plus angle C, when you add up the measurements, they equal 180. Same thing for this triangle over here, angle D plus angle E plus angle F. If I found the measurements of each of those add up to be 180. I could set those two formulas equal to each other because they both equal 180. So I could set them both equal to each other. They both equal the same number anyway. So off to the side, you could just say common sense. Angle A plus angle B plus angle C has to equal D plus E plus F, because they all equal 180 anyway, so the two sides. The 68s are the same, so I'm going to substitute in those 68s. So the 68 goes here, the 68 goes here. Right? That's angle E and C. Angle A and F were 7 degrees. So I'm going to plug those in. So this is 7, and this is 7. Right? And then I have the equal sign still between them. And I can pick any letter I want. I'll leave this angle D and angle B. Let's just leave those alone because I don't actually know what they are yet. And then what I do is to show that angle B and D, the third angles have to be equal, I can just subtract the 7 and 68 from both sides, right? Just if I, drag this angle over, subtract it from the other side, these are gone. Drag the 68 to the other side, these are gone. And do you see that it would be the measure of angle B would be equal to the measure of angle D? Do you see how that's going to work every single time? It's because of the simple fact of this. This is the reason why this thing works. It's because triangles have to be 180. It doesn't matter the type of triangle. As long as you know two of the angles, you know the third one. You can find it because it has to make 180 anyway. So it wasn't like crazy complicated looking. This simple fact is something that you can use in the middle of a problem. Like if you notice that triangles have two angles matched and one of them has a third angle marked, you can just transfer that to the other triangle like really quickly. So if for some reason, I don't have my calculator on me. We take 180, subtract the 68 and subtract the 7. If like this triangle had 105 sitting here, then I can just immediately transfer the 105 over here. Even though it doesn't have a mark there, I know the third angles have to be marked the same, so I can just automatically transfer it. So, all right, questions with this theorem? Okay, our last property today, this is pretty much the last slide I have, is this one, theorem 4.4. This theorem is not used a lot. It's kind of it's a review of some properties we talked about at the very beginning of the algebra sections. I think it was like unit 3 for us when we got into algebra and we're solving equations and stuff. It's called the reflexive, symmetric, and transitive property. So if you remember those were the properties of equality. Now they're the properties of congruence in this regard. We can use this to compare triangles if they're congruent to each other. So reflexive means I can set a triangle. So I'll just kind of pick one here. I can pick a triangle, ABC, and set it directly congruent to itself. Like that triangle is congruent to ABC. and then I can maybe in the next line of my proof, or maybe I'm trying to justify something, I can substitute this out for something that it's equal to. So I start somewhere and then I start substituting. You'll see the purpose of it later when we get into like heavy geometry proofs. This reflexive thing can actually be super useful. Right now it seems kind of stupid, but there's an actual purpose to it. Okay, so you set something congruent to itself. That's reflexive. It's like a mirror. It's reflecting. That's how I think of it. One side, the other side is exactly the same across the congruency symbol. Symmetric. You have to have one equation. So if triangle ABC is congruent to triangle DEF, then you can flip the thing around. Triangle DEF is congruent to triangle ABC. You can flip the equation around. You can like interchange the two on that congruency symbol. They can interchange. That's symmetric. We do that in algebra. If you don't remember, like some people really don't like an algebra problem written like this. They hate that. It just doesn't work for them. You're allowed to switch it. Like switch the two sides completely. That's symmetric. That's what you're doing. You're flipping the two sides. Because maybe this makes you more comfortable to solve. That was the way my math teacher always taught it. The variables have to be on the left side. It really doesn't matter. It just helps you out. Now, the reason why I would use symmetric in a problem, because I know it seems kind of, why would you use it? When you were doing a proof in geometry and you're trying to prove something is working, like something works out, you have to get the end result to match exactly how they typed it. So maybe you have to flip the equation around that you have written so that it matches perfectly for what you're trying to prove. Like it's not matched up right. So you have to like do some quick flips. And that might be the symmetric property allows you to do that. So the variable's on the left or the right side or wherever you need to do. Okay, and then transitive. Transitive is actually something I did earlier. You just didn't realize it. But it's when you compare three objects. So if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle GHI, then triangle ABC can be automatically put congruent to triangle GHI. Like you can jump. I think the example of transitive I used in class, if you remember back to last semester, I said, okay, like two students have the same age. So maybe Carly and Shelby over here have the same age. And then I say Carly, joint in the back, is the same age as Shelby. Okay? And I said, Carly Young here is, let's say 16 years old. I don't know. Then how old is Carly in the back? 16, right? You could transfer that number. I didn't tell you exactly how old she was, but you connected the dots. Like they're the same age, those two are the same age, she's 16, and you transfer the 16 all the way down to the other person. Right? People do it instinctively. It's like, oh, these are equal, this thing's equal, I can just substitute it in. Right? How you do it every day in life. You do it without even thinking about it when you have like coins and change in your pocket. If you're going to use coins to go like purchase something from the the vending machines out there. You do it all the time. You're like, oh, okay, it's $1, and you pick out 4 quarters. It didn't say 4 quarters on the screen, but you've already transited property that 4 quarters makes $1, and so 4 quarters can be plugged into that machine and it spits out the thing I want. Right? You're making those connections on the fly. Some people really struggle at transitive. Right? They don't know how to make connections. They have to be told explicitly this means this. Transitive is one of those hard things. It's like common sense. You can't teach it. You have to develop it over time. It's that idea of inductive, reasoning. It's hard to explain. You just have to learn it. So, but I did use this earlier. You didn't even realize I did it. I did it on this problem. I did it right here. I said both equations were equal to 180. And so then I just set them equal to each other. They didn't tell me I could do that. I knew that they're both equal to the same number, so they both are equal to each other. And that's how I set up my equation. I did transitive. All right, questions. I know it's a lot. I'm going to stop there. You have the rest of time today. It's not a lot of time, sorry. It took a long time. I kind of did some more talking than I wanted to. You have the rest of time to kind of work today. If you haven't checked out JMC Gradebook, do that now, please. Check out your grades. See if you're missing something. It could have been something like from last week, like, oh man, I forgot to turn in this this activity we did. Oh yeah, go get it done. Okay. All right, Alexis, Bronson, you guys are good to go. You guys can go work on your homework. Remember, we have that worksheet on Google Classroom due tomorrow. So, thanks for tuning in, guys.